Okay, here's some big terminology, not that big, but really. A limiting reactant is a starting compound or element. Okay, a starting compound or an element means it's a reactant that controls how much product is made. Here it is in a nutshell. The limiting reactant is the one that runs out first. Find that on your notes and highlight it. We're using our notes only. Find that on your notes and highlight it. The limiting reactant is the one that runs out. So highlight the term limiting reactant and the definition, the reactant that is all used up. The reactant that is all used up. Now, on your notes, define an excess reactant. An excess reactant is a reactant that does not run out. It is left over. So let's look at this depiction. Before, you have this much, a pile of red, and you have a pile of green. Then, these would be the reactants. And here are the products. It forms a pile of blue and a pile of purple. These two things combine to form these two things. What you have left over is a small amount of red. This is the excess or limiting? It is the excess reactant. The green is the limiting reactant. It is all used up during the reaction. When you run out of the limiting reaction, how much more product can you make? None. Absolutely none. When you run out of limiting reactant, the reaction stops. The reaction stops. So here we go. Let's look at this. The cheeseburger cat would like to make as many cheeseburgers as he can. He starts out with 3 patties, 4 buns, 1, 2, 3, 4, 5, 6 cheeses, and 2, 4, 6, 7 tomatoes. He can make how many cheeseburgers? If a cheeseburger consists of a hamburger patty, a bun, a piece of cheese, and a tomato, he can only make 3 cheeseburgers. What is the limiting reactant here? The hamburger patty is the limiting reactant. Our excess reactants would be the bun, the cheese, and the tomato. Everybody good there?
Yes.
All right, now I would like you to answer this question for me. How many buns were used in the formation of our product?
3.
3 buns were used. How many cheese patties were used?
3.
3 cheese were used. And how many tomatoes?
6.
I think 6.
I think it's 1 tomato per. Oh, no, it isn't. It's 2 tomatoes per, isn't it? Okay, so 6 tomatoes were used. There we go. Everybody clear on that?
Yes.
Absolutely. This is what you need to recall. The concentration of the limiting reactant is 0 after the reaction. When the limiting reactant runs out, there's no more left. The concentration is 0. What happens to the reaction when the limiting reactant runs out? The reaction stops. The only reason why this is here is I found it on the internet. And look, it had somebody that you know, and it had a chemistry term. I'm not even sure beyond that what it means, but I included it because, you know, Ryan Gosling, there you go. Chemistry and Ryan Gosling. All right, ladies and gentlemen, let's take out your notes. Find this practice problem. Before we do this, please turn your notes back to page 1. Page 1. Found it? Can we please, just for 37 seconds in time, review our problem-solving strategies? Or we're not writing anything down. We're on page 1, looking at our problem-solving strategies. Let's look and see what we recall from the last time we met. Our problem-solving strategies are this. Before you do anything, you must balance the equation. Then you identify the given and the unknown, and you put it on top of your box. Identify the mole facts that applies. I think we had 3 kinds of mole facts. The mole ratio, which was equal to the coefficient. The mass ratio, which was the coefficient times the molar mass. And the volume ratio, the coefficient times 22.4 liters. And we recall we can only use the volume ratio with gases. There's one more that I left off. What is it? The particle ratio, which is the coefficient times Avogadro's number. Okay, now back here. So, here we go. We have been told that we have 27 grams of hydrogen gas and 15 grams of oxygen gas. The question is, what is the limiting reactant? How much water is produced? And what is the excess reactant? So the first thing we should have done, and it's already done for us, was balanced the equation. Got that done. The second thing is we identified our given and our unknown. We were given 2 things, a starting amount of hydrogen and a starting amount of oxygen. And the question asked us how much water will be produced. So the relevant fact here is the mass fact, which was the molar mass of hydrogen. Hydrogen consists, H2 consists of 1 atom, just the hydrogen. How many of them? 2. Their molar mass is 1 gram. So 1 H2 has a molar mass of 2 grams. The mass fact is the coefficient times the molar mass. 2 times 2 is 4. So now we've done that for our oxygen and our water. And we see these are the facts, and our table is completely filled out. Is yours now as well? Okay. So, in order to find the limiting reactant, what we're going to do is this. We're going to test and see. If I use up all of the hydrogen, how much water will it produce? Then, if I use up all the oxygen, how much water can be produced? And we do it just like the ratio method that we did before. And the ratio method told us to take our known, which in this case is hydrogen, write what we know over its pertinent fact, making sure that these units are the same, and then we will compare it to our unknown and its mass fact, making sure that our units are the same. Then we will cross multiply 27 times 36 and then divide. According to this calculation, we can make 243 grams of water if we use up all of the hydrogen. I would now like you to find out on your own how much water can be produced if you use the complete amount of oxygen given, 15 grams. How much water can be produced with 15 grams of oxygen? Make sure you write this in the form that you've been taught, including your units. Raise your hand when you have an answer. That's correct. When I tell you you're correct, please write the limiting reactant to the right of your paper. That is correct. That's correct. Identify the limiting and excess reactant. For hydrogen, I'm going to use this bottle of hydrogen, how much water over its then I use the test how much oxygen, if I use all the oxygen over its how much water over its That's correct. That's correct. That is correct. Make sure you identify the limiting reactant and the excess reactant. That's correct. Identify the limiting reactant, the one that ran out first. Okay, I have figured out through my test that 16.9 grams of water can be formed using up all the oxygen. Now I will compare. I see that hydrogen makes 243 grams of water, and oxygen can only make 16.9 grams of water before it runs out. After it makes its 16.9 grams of water, you're out of oxygen and the reaction stops. Oxygen is the limiting reactant. You can make 16.9 grams of water. If we go back to our original question, the limiting reactant is oxygen. The amount of water that is produced is 16.9 grams. The excess reactant is hydrogen. Your notes also ask you how much hydrogen is used up. Is that correct? Okay, let's try to calculate that. Are you ready? Would you stop and think for just a moment for me? How much water is made? 16.9 grams of water is made when the oxygen runs out. That water contains all the oxygen and it contains some of the hydrogen. Is that correct? Does it contain all of the hydrogen? No. No. We want to know how much it contains. So the question says, how much hydrogen is used making water? How much water? 16.9 grams of water. Can you do that problem? Mm-hmm. What's your given? 16.9 grams of water over what? Yep, it's mass fact, 36.0 grams of water. And that's equal to our unknown. What is our unknown? How many grams of hydrogen used over its mass fact? 4 grams. When I cross multiply and then divide, x is equal to
2.
almost.
1.87.
Yep, 1.88, I think I got, grams of hydrogen are used up in making the 16.9 grams of water. Clear? Clear as mud. Okay, ladies and gentlemen, here is the next practice problem. You and somebody, an elbow partner, may do this together. You and an elbow, not an Elmo, an elbow partner may do this together.